Okay, we have 2022 ADDMA paper 2 question 10. A particle Q moves in a straight line from a fixed point O so that its velocity v meters per second is given by v is equal to 24 minus 10t plus t squared, where t is given by, where t is time in seconds. I think I skipped the line, whatever. So we have the velocity function here, which is given by v is equal to 24 minus 10t plus t squared, where t is time in seconds after leaving O. Find the value of t at which q is at instantaneous rest. So this is a very important word. I think I've seen it in almost all the past papers I've gone through. The word instantaneous rest means the object is not moving. So if the object is not moving, then v is equal to 0. Not t, please, it's v. T is the timer, so whether the object is moving or it's instantaneously at rest, the time will always be moving, but the velocity will be 0 because it's not moving. So to find the value of t when q is instantaneously at rest, you can just say v is equal to 24 minus 10 t plus t squared is equal to 0. In short, where you have a v, just put your 0 and solve for t. So with this equation, our product is 24, our sum is negative 10. So our factors should be 4 and 6. This times this, okay, we can make them negatives. So we have 24 minus 4, and then that's 40. Let's start with 6, and then minus 40 plus t squared. And then you can factor out the 6 from here. We have this. And then you can factor out the t from there. You have this. And then you have 6 minus t, then 4 minus t. So that means our t is equal to 6 or t is equal to 4. So these are the values of t at which q is at instantaneous rest. Part B, the total distance traveled in the first 6 seconds. So to find the total distance traveled, you already have the velocity function. So once you integrate this, remember the order, you have distance. When you differentiate this, that is when you divide this by t, you have velocity. When you differentiate this or divide it by t, you have acceleration. And then, so this is differentiation. And then to move backwards, I don't know. Okay, it's raining here, so I don't know if you can get me. So now, to find the total distance, you just move backwards. So from acceleration, when you integrate, you have the velocity function. When you integrate the velocity function, you move back to acceleration. So we have the velocity function, which is 24 minus 10t plus t squared. So once I integrate this, then what I'll get is the distance function. So this will be 10t plus t squared with respect to t. So my distance function will be, this one will be 24t, this will be negative 10t squared over 2, this will be 1 over 3t cubed, then plus c. And then about this c, let me just simplify it. This will be 5t squared, then plus 1 over 3t cubed. So about this C, when you look at this, we've been told that this particle is passing through a fixed point O. So let me just read the first sentence. A particle Q travels in a straight line from a fixed point O. So the fact that it says from a fixed point O, this O there is the origin, that's 0, 0, tells you that your C will be 0. If you want, you can substitute this and that. You can just try to test using this point, which is the origin, 0, 0, and then you realize that your C will be a 0. So this is my function. And then it says the total distance traveled in the first 6 seconds. So you can simply substitute your 6 there and find your total distance. So this will be 24, 6, then 5, another 6, which is like 6 squared, and then plus 1/3, 6 cubed. So now this will be 6 times 4. 6 times 4 is 24. And then 6 times 2, that's 12, plus this, so we have 144 there. And then this is 30 times 6, which is 180. And then this is like 6 times 6/3. So this is like this times this, 36 times this, 72. So you have this, and then we can simplify this. Let's start by adding. So we have this plus this is 6, 11, 216 minus 180. Then when you subtract these, you have 6 minus 0, 0, and then 21 minus 18. 21 minus 18, this is 36. So this is our total distance traveled in the first 6 seconds. And you are done.